Oh! In this video I will review and test the FlashForge Creator 3 industrial grade 3D printer. After the success of my last 3D printer review / test video, I got the Creator 3 3D printer from FlashForge and also another one, more about at the end, free of charge to make a minimum 25 minutes long review video on it. As you can see, it got even longer, but I labeled all main chapters so you can jump to your favorite ones. I was really happy when FlashForge contacted me, because that was one of my dreams to reach this point with my channel, and it just came true. And not to mention that I always wanted to own a filtered closed chamber style 3D printer, mainly because I would like to print with carbon filaments in the future without the fear of getting carbon dust everywhere. The independent dual extruder just makes it even better. This, however, does not mean that I won't tell you the truth. I work as a test engineer in my main job, and so I made this video as professional as I could. It took me more than a month, mainly because of my beginner editing skills, but hopefully you will like it. But enough talking, let's get started. So let's start with the unboxing. Look at this, they are not kidding. This is a huge package. But it is essential to protect the printer during shipping. You can see that all sides are well protected. This printer is around 40 kilograms or 88 pounds, so it is better to warm up before lifting it. Or just ask for a helping hand if you have. After taking off the side panels, I found some grip on it and could finally put it onto the table. And the best part of all unboxing is this peeling off process. At the very top you can find the user guide and the quick start guide, power cable, and here are some extra accessories like the metal scraper, the solid glue, some wrenches, grease, unclogging pin tool, and some extra Teflon tubes. Then you can also find in the package 2 kg of PLA filament, one white and the blue one, and finally the waste boxes. Inside the printer you can find 2 yellow labeled belt fixing clips, one on the x-axis and another one on the y-axis. They have to be removed before printing because that was just installed to fix the extruder position during transportation. After that we can plug in the power cord and turn on the printer. The first signs that it is alive is the fan noise. This timer that you can see I just edited onto the video. And then you can see the FlashForge logo. And after around 20 seconds you get this crazy sound, so you know that your printer booted up. Now you can raise the bed to be able to take off the last part of this packaging material. So let's assembly and calibrate the printer. The first task that we have to make is the bed leveling to avoid the nozzle to crash into the building platform before the first print. You can choose which extruder do you want to use for the bed leveling process. It doesn't really matter which one do you choose because they are on the same level. The building platform has 3 fixation points, one in the middle at the rear and 2 at the front. The rear one is fixed and the 2 at the front you can adjust. The reference point for the printer is the rear one and then goes to the front, measures the height there and then compared to the reference point and tells you how many degrees do you have to turn and in which direction. There are red and white dots on the knob. The red means 90 and the white 45 degrees. So in my case now the 225 degrees is 2 red dots and 1 white. After you adjusted the knob, you can verify your adjustment, and the extruder will measure again the height and let you know if the adjustment was right. And now we can click on the OK and repeat the same process at the last measuring point. Here's a closer look about this label. Both extruder has a piezoelectric sensor inside, which means that it has to touch the build platform and it will push up the nozzle, and so it will trigger the sensor. One more adjustment that I make is this anti-oozing plate, which is under the nozzle until it's parking in its place, and it has to touch the nozzle to not let the melted filament flow out. You can carefully bend it with your hand, just be sure that it's not too high, because probably it can erode the nozzle with time, or just false trigger the piezoelectric sensor and corrupt your print. So now you can see that it pushes down a little bit the plate, but not too much, so I'm happy with it. Regarding the quick start guide, the next step is to install the waste boxes, but since the version 2 upgrade from this printer, you don't really need them because of the anti-oozing plate, which we just adjusted before. And now it's time to load the filament. You have to take off first the side panel, and then you can push the filament into the Teflon tube through this filament sensor. After both filaments are loaded, you can click on the filament and load, and now it will heat up both extruders and you will get a sound feedback when it's finished. And here we are. By the way, I could not turn this off, just the startup sound. I don't know how is it possible. If you know it, please let me know in the comment section. The instruction says that you have to push down this knob to be able to feed the filament through the extruder, but this is just required when the extruder motor not turns, because if it's turning, you can just let the filament to feed by the extruder motor, and it will grab with the gears and it will feed the filament automatically. So once again, you can make this process till the nozzles are cold for the first time, because there is no filament inside the extruder, and then you can push down this knob, push the filament all the way into the button, and then start to warm up the nozzle and start the loading process, and it will load automatically the filament. And our next step is to calibrate the Z-axis, which is pretty straightforward. First the printer goes to the home position, and then after it we'll move both extruders into the build plate, so it can measure the height difference between the right and the left extruder. Now we can jump to the X-axis calibration. The printer first heats up the nozzles, because now we actually print with the printer at the first time. I don't know how is it with you, but I print 4 years from now and I still can stare at the printer during its work. So after the right nozzle prints a line, it goes home. And then comes the left extruder and tries to print a line aligned with the previously printed one. After it finished the print, we'll ask you if the lines are aligned or not. In our case, as you can see, the lines are really good aligned, and that's why I just going further with the next step. If you have to adjust the lines, you can make it so that you push on the no, and then with the plus minus sign you can shift the left extruder to match with the right extruder. So after the Z and X axis, the only one which left is the Y axis. This calibration process is similar with the X axis one, just now prints the line along the Y axis. The result was again really good, so I did not have to adjust anything, just go further. In the menu you can find the sensitivity option, which shows the piezoelectric sensor sensitivity in the left and right extruder. The higher the value, the lower the sensitivity. There is also an auto leveling option. If you turn on the auto leveling application, it means that it stores the calibration that we will make now, and it will apply these values before each print. If you turn on the do leveling before printing option, the printer will repeat this process every time when you start printing. If the auto leveling does not give you the desired first layer quality, you can use the Z calibration expert mode. Under this option you can find a Z calibration number and the diff number, which is basically the difference between the right and left extruder in height, and the Z calibration is the distance between the build plate and the nozzles. If you increase the number, then the gap will be bigger between the nozzle and the build plate. You can connect to this printer via Wi-Fi, Ethernet or hotspot. If we check the Wi-Fi connection, you can log in to your home network, and after, if you have the connection, the printer automatically checks if any firmware update available. If the connection was successful, you can also see a small icon on the upper right corner. As you can see, after the printer connected to the internet, I got the firmware upgrade window, so I clicked the yes. And again, a funny music. After a quick restart, you can check the new firmware version under the tools and about. Here I have to say that I made all my test prints with this firmware version. It was interesting to see that the factory already tested the printer with some filament. One very neat feature is the VLAN hotspot connectivity. If you place the printer somewhere where there is no Wi-Fi or Ethernet connection, you still can connect directly to your 3D printer via hotspot. A small icon also shows you when the hotspot is available. If you check now the Wi-Fi IP, you can realize that it has changed. It's time to print something. There was a 16GB USB stick in the package, and if we check it, we can find pre-sliced samples that you just can print immediately. Under test files, there are 3 of them. So let's start with the first file, which is a dual color mode print. The display shows you a picture about your 3D model, the remaining time which was calculated, and the actual temperatures. The print starts with the right extruder, and after it reaches the point, changing to the left extruder and continues. Another very handy feature is the removable, flexible build plate. The rough setup was good. We can see from this print that the two nozzles are well aligned. A little blob from the nozzle change is there, and you can see the seams, but the quality is pretty good, I think. This is not an error, it was in the model some kind of sign, but I don't know what does it mean. After I removed the print, I just realized that the build platform is moving around too much. So I checked the screws and I realized that these 4 screws here were loose. So I just fastened them and then it solves the problem. The next file in the row was a mirror mode printing. Because this printer uses an IDEX technology, which means it has an independent dual extruder system, you can print in mirror mode or duplicate mode with it. During printing you can turn on and off the lights. If you don't want to stare it, then you can turn it off. There is also a Z-axis compensation option, but this works just before the print started. So for example, if you know that the layer is too high, you can restart the print, and before the first layer printed, you can adjust the first layer height. The third file on the stick is a dual color print with multiple extruder changes during the print process. This part was printed with a wall around it, which prevents against deflects caused by the oozing filament during the travel movement of the extruder between the parking position and the printed part. Let's check what's on the pen drive. We have the flash print. This is the slicer. 2 guides, the quick start and the user guide. The test files that we already printed. And some videos about the setup process. Okay, regarding the user guides, I would recommend you to use the ones which are on the pen drive, because the printed one is an older version. If we check, you can see that the number is 4 and this is number 3 version. And if we go to the page where it shows what's in the kit, then you can clearly see the difference. And this one is the difference, the nozzle brush. I spent some time to look for it in the package. But now you know. You can also find an option in the menu where you can choose between the steel brush and the anti-oozing plate. As far as I know, since 2019 December, all Creator 3 printers are version 2 ones. If you are wondering what are the differences between the version 1 and version 2 printers, the enhanced extruder design, the removable magnetic build plate, 4 fans at the back from which 2 blows in fresh cold air to the extruders, and the other 2 sucks out the air from the chamber through a filter, and finally a more universal spool holder design. Speaking about the spool holder, I took some filament spools that I had at home and tried them out. But as you can see, small, narrow spools are no problem, but wider ones are still not compatible. I also measured the absolute maximum size which still fits and end up with these numbers. The maximum width is 70 mm or 2.8 inches. Maximum diameter is 210 mm or 8.3 inches, and the minimum hole size is 40 mm or 1.6 inches. Filaments that are sensible for humidity like PVA, TPU, PC or PTG are not required to store here, because during the printing it can absorb water from the humid air. I also made a dry box solution for my filaments. If you are interested to make it, I put a link into the description where I show how can you make your own. But there is no hole here where you can feed the filaments through without taking off the side panels, which ruins the closed chamber concept if you are planning to use this kind of filaments with this printer. And my favorite part is the testing. Because the build platform flatness is a very serious requirement by 3D printing, I installed a digital dial gauge onto the right extruder stepper motor with a double-sided tape, which is not professional but it's good enough for this job now. With the help of the FlashPrint Slicer software, we can connect to the printer and move the head and build platform from your PC. This way we can also set up a reference 0 point where we can go back easily all the time when we need it. When I leveled the build platform with the built-in leveling function, I always got a minimum 45 degrees value for adjustment. But I wanted to make it more precise, and in this way I could level the platform much better. After I finished the leveling, I went back to the saved 0 point and checked the build platform level in an H letter shape. By the way, the left camera picture comes from the built-in camera, which this 3D printer also has out of the box. The resolution, however, is fairly low with its 800 x 600 pixels or half a megapixel, but it is good enough to check out our 3D printing process time to time. As you can see, the fluctuation is inside the 1/10 of a millimeter range, so I am happy with this result. The next test shows the noise level and power measurement in different stages. This printer has two LED lights, one called flashlight, which lights up the printing chamber, and the other one called the ambient light is the FlashForge logo background light. Now I just turn them on and off, but as you can see it is possible to set up their brightness also. If you turn off both lights, you can save around 4.5 watts. The preheating power is pretty much the same as the preheating at the start of a 3D print. I just would like to show you that it does not matter what is the setup temperature, till the build platform reaches that level, it will give its maximum power. That is another question, how much power does it need to keep the platform on this temperature? It depends on the temperature difference between the build platform and its ambient temperature. In our case, the printing chamber helps to keep the surrounding air warm and so minimizing the heating power requirements and costs. Now I heat up the build plate and the two extruders simultaneously, and so we can see that the power difference is around 100 watt, which means that each extruder probably equipped with a 50 watt heat cartridge, which is needed to handle such a high temperature as 300-320 degrees Celsius, which this printer capable of. For comparison, a Prusa MK3 3D printer uses a 40 watt version. In the following I tested how much time does the build platform need to heat up from 25 to 100 degrees Celsius, and also how does the temperature distribution look. As you can see, it takes around 12 minutes to reach this temperature. The printer is also equipped with filament runout sensors. In this test I check what is happening if the filament runs out. As you can see, after the sensor was triggered, the printer prints a little bit more and then stops printing and moves back to its parking position. After it reached that, it will give you a sound feedback. Now you have to first unload manually the filament which was run out, and then you have to reload it. After you pulled out the filament from the Teflon tube, you can start the reloading process. It would be nice if the printer prints further after a filament run out event to use up the rest of the filament from the Teflon tube. It has a fixed length, so it would be just some changes on the firmware to do that. When I finished the unloading process, the extruder moved back over the anti-oozing plate. So now when I load the filament again, it cannot flow out. I had to press Done and OK to get the extruder back again to the open area, but now it starts oozing the filament, so I started again the loading process, and after that it moved back finally to the right position. These movements are clearly changed up, which should be fixed. As you can see, the filament runout event is pretty complex. It could be as easy as letting the Teflon tube length printing, then automatically unload the filament and prompt the user to remove the rest and reload the filament. So speaking about modifying the firmware, I collected several issues that hopefully FlashForge will fix in the future and make this printer more user-friendly and more efficient printer. For example, when you pause the print, the build platform moves down and the extruders are going to the back of the printer. Till this point is fine, but after you continue your print, the build platform moves back first, and then the extruder comes back its restarting point. I would prefer the exact opposite movement by restarting the print as pausing it, which means move back the extruder to their position where the print was paused, so you have a good clearance between the extruder and the already printed parts, and just after this point raise the build platform back. Now I stopped the left extruder, and as you can see, the extruder stays where you stopped it. I would prefer to let it go back to its parking position. In this shaky close-up you can see that the movement stopped, but the filament is oozing further out from the extruder. Another not optimal movement order when you use a so-called Z-hop between extruder changes, and when one extruder finishes its job, the build plate moves down and the extruder parks, but then before the other extruder comes, the build platform moves up first, and just after that comes the extruder. It is more risky as the other way around. The auto-leveling process could be also much faster with not moving the build platform so far from the extruder between all measuring points. It would be enough to use 1 or 2 mm of clearance, and so it would not take one cycle 13 seconds long, just around 2. So by the 9 measuring points it means 100-second faster leveling, which compared to the actual 127 seconds is a 470% quicker solution. And you know, time is money. If you look it closer, the right extruder have not parked back over the anti-oozing plate, and it is now waiting for the heat up process before a print. So it means when it starts printing, you have a good chance to have oozed out filament right at the start. Restart a print with auto leveling can take almost 5 minutes long, because the extruders have to cool down before the leveling process. When you manually pause a print, it has a delay which can be fairly long, as you can see here. It is not that big of an issue, just good to know. If you want to pause your print to insert, for example, magnets or nuts into them, then you should use the pause at height slicer settings. With this option, the printer will automatically pause the print at the given height. During printing, there is a Z-axis compensation option, which just applies to the following layer rather than the actually printed one, which makes this feature pretty much useless. It would be nice to see a live height adjustment solution here. Another nice feature would be a smarter extruder heating solution. Now if you print something like this sample, the printer will heat up both extruders from the beginning, even if there is just a little white part at the very end of your print process. The white extruder stays also warm for the whole printing time, which can easily cause clogging with time because of the burnt filament inside the nozzle. And finally, the vibrations. The printer is equipped with 12mm linear rods, which is a huge mess, and also pretty much an overkill in my opinion. Probably a 10mm or even an 8mm rod would be enough. The beds, however, seem to be too small for this mess. I would go with a 10mm bright one. This moving mess causing a lot of vibrations that you can see here. I plan to put this printer next to my Ender 5 Plus, but seeing that I have to find out some dampening solution. Probably a rubber mat would work to be able to print with both printers simultaneously without any issues. Let's start first with the cons. Noise level. This printer with its 60 decibels is definitely loud. You don't want to be in the same room when it prints. Mainly this noise is caused by the fans, and it has minimum 8 of them. 4 for the chamber filtration, 2 for the extruders, and another 2 for the electronic parts. Constant part cooling. You cannot turn off the part cooling because it's shared with the heat break cooling fan. Some high temp materials though, like ABS, PC or nylon, do not require part cooling to reach better layer adhesion. What you can do basically, print a little cap and put it onto the fan exhaust to block its airflow. Slow start and restart time. Limited slicer compatibility. Other than the stock flash print slicer, which is not so advanced yet, you can use the Cura and Simplify 3D slicers, but there are no official printer profiles available. I just could find some on Thingiverse and on the Creator 3 Facebook group. I put the links into the description if you're interested. Buggy firmware. As you could see, there is a huge potential for further improvements, but hopefully my feedback will also help to eliminate these issues. And finally, the vibrations. And the pros. Pre-assembly printer. Closed and filtered chamber. Perfect for printing filaments like ABS, ASA, PC, nylon and carbon field ones. 9-point auto leveling. An IDEX system. Independent dual extruder system which makes possible to print 2 parts at the same time in mirror or duplicate mode. No perch tower needed by filament change, and so it prints quicker. High temperature printing. Up to 300 degrees Celsius with the stock or 320 degrees Celsius with a hardened nozzle, which are available in 0.4 or 0.6 mm diameter. Removable magnetic build plate. For connectivity, Wi-Fi, hotspot, Ethernet and flash cloud. A built-in camera. And finally, a multi-machine control. This is really helpful if you use more printers simultaneously. As a conclusion, I think this 3D printer has a solid hardware which has less advanced firmware and slicer solutions. After FlashForge developed them further, what they continuously do, it has the potential to be one of the best price to quality ratio, professional, closed-chambered with independent dual extruder equipped 3D printer on the market. And as I said at the beginning, I got 2 printers from FlashForge. The other one is the Creator Pro 2, which is more of a consumer level 3D printer. If you're curious about that review also, then consider to subscribe to my channel and ring the bell to get notified when I'm uploading that video. Till then, happy printing and see you next time!